Hello all. In this lecture we will see about software requirement specification. So in the previous lecture we have seen how to gather the requirements and how to analyze those requirements. So after analyzing these requirements we need to document these requirements. So that is the next step. So in this step we will be specifying these requirements. So we have a software requirement specification document. We call it as SRS. So after gathering all these requirements and after analyzing, it should be documented. So it is documented in an SRS format, and there is a IEEE standard format for this SRS documentation. So this SRS document we have to take much care to prepare this SRS document, because this SRS document is used by many type of people. So for example, the users, customers and marketing personnel use this one. So users and customers are the stakeholders. They need to refer the SRS document to see whether all the requirements have been mentioned in the SRS. And also this marketing personnel. If you are developing some generic product, if you are developing an office package, or if you are developing an accounting software, the marketing personnel has to take it to the market. They have to discuss with the clients, so they need to understand what is the software. So how to understand what is the software, you need to properly document it. So it is documented using this SRS. Then we have software developers. So after completing this analysis, this SRS document is given to the design team as well as the coding team. So the design team, what they do is they will be designing based on this SRS. So it is the document that will be used by the developers. So we need to do it so that there is no error in this SRS. Then the test engineers, the testing team, the software testing team will also be referring the software requirement specification. So as soon as the SRS is complete, the testing team can start their work. What they do will, in the SRS document there is functional requirement and non-functional requirements. So based on these requirements, they will be writing their test plans, so that after completion of coding, they can start their testing. So soon after completion of SRS, the test team will start writing the test plans based on this SRS. Then it is used by user documentation writers. So there are user documentation writers, or the user manuals are prepared by some people. So they need to have a proper understanding of the software. So for that they will be referring this SRS document. Then the project managers, so they have to estimate the cost of the project. So all of the schedule, everything is based on this SRS. So the project managers will be using this SRS document. Then the maintenance engineers, so finally after the product is delivered, and if there are some bugs which is reported by the customer, it has to be cleared. So in order to clear that bug, or in order to change those requirements or to add new requirements, the maintenance team will have to refer this SRS. Then only they can make those modifications. So this SRS is an important document in software development life cycle. And also this will be a contract between, this will the basis for the contract between the company and the customer also. So that is why SRS is an important document. So why should we spend this much time and resource to develop an SRS document? So this is very important. So why should we spend this much time and resource for this SRS document? So first thing is, it forms an agreement between the customers and the developers. So after completion of this documentation, it will be given to the customers, and the customer will review it. And if there are any changes, they will make those changes, and finally they will finalize that requirements. So it is a form of agreement between the customer and the developer. And also the contract also is signed after this SRS is completed. Then we can reduce future reworks. If we prepare a proper SRS, then uh, there won't be any changes in the later stages. Otherwise what happens is, the customer will mention some other requirements in the later stage, and we have to add these requirements, and we have to redesign, we have to recode, and we have to retest. Everything should be done again. So in order to avoid those things, a proper, we have to spend much time to prepare this SRS without any errors. Then it also provides a basis for estimating cost and schedules. So already we have seen that. So without preparing SRS also we can estimate the cost and schedule. But after preparation of SRS, it will be much more accurate to prepare this cost and schedule, because we know which all functions are there, which all functionalities are there in the software. So based on that functionalities, we have already seen how to estimate the cost, schedule, everything. So all those things, for estimating all those things, this SRS will be a basis. Then it also provides a baseline for validation and verification, because this SRS, the final software, is checked or validated and verified based on this SRS. So all the test plan is done, or the test cases are designed based on this SRS. So test engineers will be designing the test plan based on this SRS. So all those verification and validation is done by the test engineers based on this SRS preparation. And also it facilitates future extension. So in SRS document there will be provision to add future extensions also. Future enhancements is also possible, and it can be added to the SRS in the later stages. So that is why we have to spend time and resource in preparing this SRS without any errors. So next we will see characteristics of good SRS document. So this is actually a skill. There is a skill in writing this SRS document without any errors. So there is a standard for writing this SRS document. Earlier it was IEEE 830. Now there is another standard which was introduced in 2018. So I'll explain it about the new standard later. So characteristics of good SRS. So first characteristic is it should be concise. So it should be concise means it should be written in simple words and it should be clear. There should not be any ambiguity. It should be consistent and it should be complete. So we have already seen the SRS should be unambiguous, consistent, and complete. So and it should be simple and it should be easily readable, because this is given to the customer to for review. So he should understand what is written. So it should be written in simple English. Then SRS should be implementation independent. That is, always analysts used to make mistake that they will add some implementation details in the SRS. So it should be actually an implementation free document. That is, we should not write anything about the implementation details. We should not say that this thing should be done. For example, the table should have this many number of columns, or the primary key of that table should be like this. We should not mention those implementation kind of details in this design, or the design kind of things in the SRS document. So it should be free from this implementation part. It should be like a black box. So it should be like a black box. We should not be able to see what is inside it. Okay, the SRS document should only mention what is to be done. It should not be, we should not mention how it is to be done. Okay, how should not be mentioned. Only what is to be done should be mentioned in the good SRS. Then it should be traceable. Traceable means, so if we have designed some elements of this SRS, then that design should be traceable back to the SRS. And also if we have coded something, it should be traceable back to design, and it should be again back traceable to the SRS document. So whatever is written in the requirements only should be coded or designed and coded. So whatever coded should be traced back to the requirements document. So if we see something in the coding part, and if we want to refer, we can easily go to the SRS and see that this is the thing that we have coded. So it should be traceable in both ways. Then another characteristic, it should be modifiable. So the customers will frequently change the requirements during the software development. So if we want to make these revisions, there should be provision to make this changes in the SRS document. So we cannot say that SRS document will be complete soon after the analysis phase is over. Again, there will be some enhancements in the future. So all those enhancements should be able to be added into this document in later stages also. So that is why we call it as it should be modifiable. Okay. Then another characteristic of a good SRS is the identification of response to undesired events. So if there are undesired or exceptional conditions that may arise when we run this software, all those things should also be mentioned in the SRS document. Then it should be verifiable. So it should be verifiable means it means we should be able to verify whatever requirements that we have done. That is, the test cases will be designed based on these requirements, and when we test the system, we can say that all these requirements have been satisfied. So when we write in the SRS, the requirement should be a verifiable thing. Okay. So that is another good character, characteristics that should be there in SRS document. Next, we'll see what all attributes contribute to the bad SRS document. So first one is over specification. That is, over specification means earlier I have mentioned that how to do a thing should not be mentioned in the SRS. We should mention only what should be done. We should not mention how to do. For example, if you are storing some data about a student, then we should not mention that student data should be stored in files, or it should be stored in this database. Like that, we should not mention. So that is what we call as over specification. We should mention only what should be done. How it is to be done should not be mentioned in a SRS document. Then another bad attribute that will contribute to this SRS is forward references. So usually when people write this SRS, there will be forward referencing. That is, I will, for example, if you are writing something about a software and if you mention it will be explained later, it's not a good thing. We should mention whatever is there at that point itself. We should not say that it will be explained later in the next session or like that. So there should not be any forward references in the SRS. Then wishful thinking should be avoided, because users what they do is they will write something in the SRS that is which will not be able to be implemented. That is known as wishful thinking. So we should not write which is very difficult to implement. We should include only those things that can be implemented. Then there is a possibility of noise in the SRS. So noise means presence of irrelevant things in the software development. So for example, if we write something about a college automation system and if we say that office work will come at 9:30 and will go at 5:30, it is an unwanted thing in the SRS document because it has no relationship with the software what we are going to develop. So those are known as irrelevant things. So we should not include irrelevant things in the SRS document. Okay. So these are just some of the attributes that contribute to the bad SRS. There may be other attributes also. Okay. So next we will see categories of customer requirements. So we will be mentioning the requirements in the software requirement document. So, as per the IEEE 830 guidelines, this was introduced in 1993. IEEE standard is there for writing SRS. So, this 830 was introduced in 1993. Again, it was revised in 1998. After that, again, it was revised in 2011. Now, we have a 2018 standard also. So, the main categories are, as mentioned in the IEEE standard, is functional requirements. Then it should contain non-functional requirements. Under this non-functional requirements, we can classify into design and implementation constraints, external interfaces required, then other non-functional requirements. And also third category is goals of implementation. So mainly we have three categories of customer requirements. One is functional requirements, non-functional requirements, and goals of implementation. Under non-functional, we have three: design and implementation constraint, then external interfaces required, other non-functional requirements. So we'll see each one separately. So first one is functional requirement. So functional requirements capture the functionalities required from the system. So this mainly deals with the functionalities of the system. So this is the most important part. This can be considered as the most important part in an SRS document, because the developer will be developing all these functionalities. So all the functionalities that will be there for the software will be specified in this functional requirements. So if we have a functionality like F5, then a functionality means a functional requirement means there will be some input that will be given to this functionality, and the input data will be some transformed to some other output data. So if there is a transformation from input to output, then this can be considered as a functional requirement. So based on this, we have to identify all the functionalities that will be performed by the system. So it will belong to this functional requirements. Okay. So in this way we can classify the functional requirements. So that is the first case. Then next we have non-functional requirements. So non-functional requirements deal with the characteristics of the system which cannot be expressed as functions. So those things which cannot be expressed as functions will belong to the category of non-functional requirements. So we have already seen under non-functional requirements we have three: design and implementation, external interface, and all this will come under non-functional requirements. So it deals with the characteristics of the system which cannot be expressed as functions. For example, maintainability of the system, how long we will be maintaining the system, or how frequently we will be maintaining the system, or portability of the system, whether this system is portable to Unix system, or whether it can be implemented in Android, like that, the portability of the system, or usability of the system, how the graphical user interface will be. All this will come under this usability of the system. Then reliability is used. Then concurrent accuracy of results, number of concurrent users that is possible for running this software. So all this will come under throughput, transactions, for how many transactions per second, like all those things which cannot be dealt as functional thing will be expressed as non-functional requirements. So these will form a basis for in the case of testing. When we test, we will have these things should be shown. So if we mention that we can support 1 million users per second, then at the time of testing we should simulate and show that this online website or this website can support up to 1 million users at a particular amount of time. Okay. So all these functional requirements will be mentioned under this non-functional requirements. So in under this non-functional requirements, we have this design and implementation constraints. So it deals with the corporate or regulatory policies. All will come under this design and implementation constraints. So this category of non-functional describes any items or issues that will limit the options available to the developers. So there will be some constraints for the developers, to the developers. We will say this policy is applicable. So example, corporate or regulatory policies. For example, we cannot develop a software for doing this casino type of things online. So that is a violation of our law. So those corporate or regulatory policies which are violated, these will form under this constraint. Then hardware limitations, we might have some hardware limitations also. For example, if you are going to develop a software for a particular college and they say they don't have money to buy a server, so it should be installed in an ordinary system. So in this case we will mention that this is a maximum hardware that is possible. So based on that we have to develop a software. The interfaces with other applications, if this is interfacing with other applications, what all applications it should be interface. Then use of specific tools, technologies or database. So we can mention that we can use only Oracle database or we can use only MySQL database. So those type of constraints, so these are actually the constraints that are which limits the options available to the developers. So developers should develop based on these things, and also specific communication protocols or we security considerations or programming standards that should be used, all will come under this design and implementation constraints. So this will limit the options available to the developers. This is for the developers to see what they should do, and what these constraints are mainly for the developers. Then another category non-functional requirement is external interfaces required. So these external interfaces may be hardware, software, or communication interfaces, then user interfaces, report formats, all these things will come under this external interfaces. So how this GUI should be, what are the styles, what the screen layout should be, what are the standard buttons should be, there should be, or the help functionality that should be there, where should the help button be, what all share keyboard here shortcuts should be there, or the error message display standards if there are any, all this will come under this external interfaces required. Okay, reports, formats, etc. Then we have other non-functional requirements. So this is actually neither design constraints nor external interface constraints. Okay, so main things that will come under this is performance requirement. So how many transactions can be done per units per second? All those things will come under performance, or the reliability of the system, how much reliable is the system, or the accuracy of results, how much accurate our system are, the security measures, all this will come under this non-functional, other non-functional requirements. So non-functional requirements we have to classify into three. First one is design and implementation consideration, and second is external interfaces, and third is other non-functional requirements. Then after that, another type of requirements will be goals of implementation that will be mentioned in the SRS. These are actually some suggestions. These suggestions may not be used, or may not be tested after completion of the software. So these are just suggestions. See, these are just suggestions regarding the software that is to be developed. So mainly it deals with the revisions to the system functionalities in the future time. So if we want to change some modifications, or we want to make some modifications in the future, this goals of implementation document will help. So we will say that today we will be developing the software only to support fingerprint identification. Tomorrow we may go for some image type of recognition. Then those when the developers develop the software, these goals of implementation should be considered, so that in future we can add those technologies also. Okay, so that is what we call as goals of goals of implementation. So all these will be some new devices to be supported. Maybe in future we will add some more devices. Currently we require only Android app. Tomorrow we will be adding iOS app. So we will mention in the goals of implementation. In future there we have plans to add this thing also. So when the developer develops a software, he will keep it in mind. So in that way we can develop the software also. And also reusability issues. So if we want to reuse some parts of the software also, it can also be mentioned in the goals of implementation part. So these are the three main categories of requirements. Then how to identify the functional requirements. So the important thing in this software SRS document is the identification of this functional requirements. So what we have to do is we have to find the high level requirements first. We have to identify the high level functional requirements, and these high level functional requirements are split up into or subdivided into small categories or sub functions. So if we want, for example, if we want to if you are developing a banking software, and if you want to uh, if we have a functionality that is to deposit or withdraw some cash, then withdraw cash is a high level requirement. So we try to categorize into that the main withdraw cash into sub functions, and we try to develop what is the input to that system, what is the output of that system, what is the processing that is happening inside the system. So we'll see one example for this how to identify. So consider the case of this library software. So if we have a search book function, then the input, what is the input to that function? An author's name, and the output is the details of the author's book and the location of these books in the library. So this is one of the functional requirements. So in this way we will identify each functional requirement, and what we do is we try to find out what is the input to that system and what will be the output from the system. So based on this, we can document this functional requirements. So this is how we document this functional requirements. So this is withdraw cash from ATM example. So we have withdraw cash, and we write the description, what is it happening inside that. It is a brief description of what is happening. Then under R1 we will be properly numbering it. It means under this R1.1 will happen. Select withdraw amount option. Input is this, output is this. Then under this 1.2 will happen. After this 1.2 will happen. Select account type, input. Then there will be output. There may be under 1.2 there may be subheadings like 1.2.1, 1.2.2 like that. We can number it. Then 1.3 it is required amount like that. Everything will be documented like this. So the proper documentation should be done for each function required. So this is the whole function, and we try to find out the some functions inside that, and we document based on the input and output of each function. So there is a standard for this SRS. There is a standard way to organize this requirements. This is IEEE 29148 standard that is currently used. It was developed in 2018. So if you check this is a this is a whole document which consists of the content. So this is a whole document, IEEE standard. You can search in the net, you will get from the IEEE site itself, you will get this document. So it consists of different parts. Everything is mentioned. Who is a stakeholder, what you mean the stakeholder, what are the requirements, all these things are documented properly. And under this, what you have to go through is, you can go directly to, there is a stakeholder requirement specification also, there is business requirement specification document is also there. Then you have system requirement specification. Here we have 9.6, we have software requirement specification. So if we go to the software requirement specification, we will get an idea of what is happening inside the system. The purpose, the scope should be mentioned, everything will be. So this way you have to document. So for the assignment I have given, next step is to write the SRS of your software. So in that you have to go through this document properly, and then you have to prepare that SRS. For you have to see what is the purpose of this software, then scope of that software. Then you have to mention next is product perspective. So what all things should be there in the product perspective is mentioned in this document. The system interface, what is the system interface, what is this user interface, everything is mentioned here. The communication interface, all these interfaces. Then comes the for product functions, then user characteristics, then what all limitations are there, all these things will be mentioned. Then the specified requirements. Then after that we will have the functions, different functionalities of the system. Then usability requirements, performance, logical database, design constraints, standards, then software system attributes. All these things will be mentioned in this order. So there will be a reference documents also. You can check other documents also. You can see how an SRS is written. So this is the standard for SRS document. IEEE standard 29148 2018. So it was modified in 2018. So next is how to represent complex logic. So you should refer the latest standard when you write your SRS. Okay. So next is techniques for representing complex logic. So if there is a complex logic in the SRS in the requirements, how to represent it? So we have two ways to represent this complex logic. One is decision tree and second is decision table. So in decision tree, it is actually a graphical view of the processing logic involved in decision making and the corresponding what actions should be taken. Then edges of a decision tree represents conditions, and leaf nodes represents the actions to be performed depending on the outcome of the testing of the condition. So I will show an example, then you will understand what is this decision tree. So if we have an library membership automation software where it has three options. What's this new member? So if you have a new member, what should be done? If there is renewal, what should be done? If it is cancel membership, what is to be done? So new member, under this we have to make a decision. When a new member is selection is opted, the software should enter the details of the person. So this is the action that should be taken. That membership record should be updated, bill should be generated, a security deposit should be paid. All those updations should be done. Then if it is renewal option, this is a decision and this is the action should be mentioned, should be performed. And if it is cancelled, this is the decision and this is action. So this is actually a complex logic. So we cannot represent using a simple functional requirements. So when you write your SRS, you can include use case diagram also. So if you mention those diagrams, and you can include other sequence diagrams also. If you draw those sequence diagrams like activity diagram and all, you can mention in the SRS. So if you draw those diagram, if you have that diagrammatic representation, that will be easier to the for the user to understand the flow of all those things. So it is better to include diagrams also in SRS. Okay. Anyway, we'll come back to this example. So if we could represent this complete logic in a pictorial way, it will be much more easier to understand for the user. For example, the same thing can be mentioned like this. So if there is a user input, then if it is a valid selection, if it is not valid, then we can simply mention it is an error. If it is an invalid input, or if it is new member, this should be done. If it is renewal, this should be done. Or if it is cancellation, all these activities should be done. So this is what we have mentioned here. So it is a graphic view. So edges correspond to these conditions and leaf node represents the action. So these are the conditions and these represents the actions. So if it is a new member, these actions should be performed. If it is renewal, these three actions: ask for membership details, update expiry date, and print bill. So in this way, we can represent a complex logic. So we have represented all the three things here. So this is how we can represent. So this is known as decision tree method. Then there is another method, we call it as decision table method. So it is used to represent in a tabular or matrix form. So upper rows of the table specify the variables or conditions to be evaluated, and lower rows of the table specify the actions to be taken. So here we have a matrix. The upper rows will represent the conditions and lower rows will represent actions. Okay. So here a rule implies that if a condition is true, then this action should be taken. So we have each column there, we call it as a rule. So we'll see an example, then you'll understand. The same thing, the previous example we have seen the LMS software, the same thing can be represented using a decision table. So the top rows will represent the conditions and the bottom rows, the lower rows will represent the actions. So the top rows will represent the conditions and the bottom rows or the lower rows will represent the actions to be taken. So if it is a valid selection, if it is no, then we have to, here there is an X mark. This means display error message. Then if it is a valid selection, yes, and if it is a new member, and if it is not renewal and not cancellation, then these three things should be done: ask members details, build customer record, generate bill. Then if it is valid selection and it is not new member, if it is a renewal, then these three actions should be taken. So this is actually, all columns can be considered as a rule. So this is a rule. There are 4 rules to be done for that software. So each column will represent a rule. So what should be taken if this condition happens? Okay. So this is decision table method. Now we will compare this decision tree and decision table. So even though both can be used to represent this complex logic, uh, we have to consider three factors. First is readability. So decision trees are easier to read. We have already seen that in the example. So decision trees are very easy to read and understand when the number of conditions are small. So if the number of conditions are small, then the readability is good in the case of decision tree. So yeah, in the case of decision table, the advantage is the developer can go through all the possible combinations of the conditions. That is the advantage of decision table. So in the matrix format, we can get into all the conditions that are possible. So that is possible only in the case of this matrix format. Okay. Then second thing that should be considered is explicit representation of the order of decision making. So in the case of decision tree, we know the order of processing, how the order should be. So if you consider this decision tree, we know what is the order. So this is the first step, this is second step, this is third step. This is the first, this is second, this is third step. So we know the order in the case of decision tree. But in the case of decision table, we cannot specify the order. So we are just marking it as a X. We don't know whether this should happen first or this should happen first or this should happen first. So we cannot specify the order in the case of decision table. So in the case of decision tree, we can specify the order also. Then third is representing complex decision logic. So decision trees become very complex to understand when the number of conditions is increased and the actions that are to be taken is increased to a level, then decision tree will be very difficult to understand. So in those cases, decision metrics or the decision table format will be better. So in order to represent this complex decision logic, it will be better to use this decision table format. Okay, so that's all about software requirement specification. So what you have seen is how to write a good SRS and how to document that SRS using the IEEE standard format. And in order to represent this complex logic, you can use decision tree and table, and you can use use case diagrams or activity diagrams to represent complex logic, or you should use this use case diagram inside the SRS document also. And also the activity diagram can also be included in the SRS document. So that's all. Thank you.